Okay, so looking at what I have on the breadboard compared to what I have in my schematic, this op amp and this transistor are doing what I want them to do, and basically the transistor is acting as a switch for this line down to the capacitor and then onto the non-inverting input there. And let's see here. So the transistor there, we got 0 volts, and as soon as the non-inverting input comes off the ground, or gets, really higher than the inverting input, the transistor starts putting out 1.06 volts. And that's great for a switch, for a logical switch, but that might prove to be a little bit of a challenge for this capacitor. And the reason being, and my reasoning here, is that what's going to happen is the temperature will rise, and that will cause the resistance on the thermistor to drop, which will cause the voltage on the non-inverting input to fall. And when that does, eventually it'll fall below the non-inverting input, and then cause the op-amp output to rail low. And what that'll end up doing is opening up the transistor, basically, flipping that switch. And that is the behavior that I am seeing from the circuit. And the transistor, it doesn't get too hot there, not anymore. When I have it wired up wrong, it's hot. So yeah, I mean, right there we can see, I have a 0 or I have a 1, so, and it's a consistent and steady voltage right there. And of course, I can pull that up a little, and I'm still getting the same behavior, so I can kind of play chasing with the inputs there. Let's see here. Turn that one all the way up, and I didn't do what I wanted it to. Oh, that's because I don't have it connected. I actually, I took the non-inverting input and I actually railed it to ground. So yeah, that just kind of tells me now right here, okay, well, blah, blah, blah. So if I take this non-inverting input here, we can, play around with right there. So yeah, take the non-inverting input, turn it up a little, bam. Take the take the inverting input and turn that up without jiggling the wires. Boom, I can rail it back down. And I'm just turning the potentiometers up one after the other. So yeah, there you go. So that shows you right there, you can tell, which is higher. And that's using the op amp as a comparator. Or I can just, take that and, plug the non-inverting input straight into the ground, and then I can, determine, if or take my inverting input and put it to the ground, and then determine if my non-inverting input is, ground or not. And then, the resistor, just, it happily does its thing, or the transistor happily does its thing. So there we go. So yeah, the next big thing I'm going to have to figure out then is whether or not 1 volt of current is going to be enough to charge this capacitor sufficiently to get a decent amount of charge on there. Because what I'm thinking is when this transistor closes and it starts, goes back to a logical 0, this capacitor is then going to start discharging into the inverting input of the next op amp. And what that will allow is for, my temperature sensing portion of the circuit, and then I'll have a timing portion of the circuit, and based on, how fast that capacitor discharges. So yeah, that's the next bit, is to get a capacitor on the board and see if we can, charge that up effectively. And if we're charging that capacitor up effectively and allowing it to discharge properly, then yeah, everything should be working, and we should be getting into the, the op amp input right there. One thing I am going to want to make sure of, though, is maybe check the output voltage of that capacitor. I don't want it to, potentially send too much into the